the next part of the processing and understanding of organic chemistry, we need to look at some standard reactions. If we go back, right, remember we had standard acid plus a metal gave us this. Acid plus a metal oxide did this. Acid plus a carbonate, for example, gave us, we had certain standard reactions that we had to learn. Now, in the process of organic chemistry, there are a set of standard reactions that we have to know. So let us just start with these standard reactions. Okay, what are they first of all? Well, the first one we're going to do is we're going to look at the oxidation. Okay, the oxidation is the addition of an oxygen, all right, to something. Now, I'm going to take an alcohol and add oxygen to it. This is an old saying that if a wine corks, you get vinegar that you can put on your fish and chips. I don't know if that's an old British saying or where it comes from, but essentially what they're saying is wine turns to vinegar if you put oxygen. Oxidation is the, let me not use the word addition of oxygen, exposure, O2 exposure. All right? What is actually happening here is I have got an alcohol. I am going to do a standard one, an alcohol plus oxygen gas goes to an acid plus water. It's a standard reaction. So let us take ethanol, meth, eth, and here we go, methanol. There's our alcohol, right? Plus we're going to add O2, we're going to form an acid, and we're going to form water. Let's just understand what is happening here, okay? Let's just break the reaction down. We know we're getting water, right? So let's have a look here. This guy here has got that. I'm going to do a little sub-breakdown here. This is an O, and that's another O. There are two oxygens, correct? I haven't balanced this thing yet, just mind you. Okay? But now I need an acid. This is an organic. This is organic. Isn't it the alcohol? So I'm going to get an organic acid. I'm just using logic here, right? An organic acid. What are the only acids we know in organic chemistry? Carboxylic. So we're going to get an oic. We're going to get an oic acid, aren't we? And we've got here methanol. So guess what? We have to get ethanoic. Why? Why do I have to get ethanoic acid? This goes right back to the early grades in chemistry. All we have is two carbons, a bunch of hydrogens, and an O and an H. That's all we've got, right? So we have to balance it out and end up with an ethanoic acid because they've told us you must find an acid in this process. Now, it's organic. So therefore, what are we saying? We're actually saying that this is what is going to happen. The C and the C change, all right? The OH stays because I know that. Over the top there, I had two hydrogens. Those two hydrogens come off. They are these ones here. Okay? They come off. And the two hydrogens form with that to form the water. Okay? So the alcohol loses two hydrogens, they come off, and then the alcohol actually changes to this. So I end up with that double bond O and an OH over there. So what happened is, in order to do that, this bond, there's a gap here now, and there's a gap here. This one shifted up to the top to give me my two gaps, so that the oxygen can come in because O is a -2. So it needs two electrons to bond to. So I created the COO bond, the C double bond to an O, not COO. The C double bond O was created. So there you have that ethanoic acid. Ethanoic acid is in fact also known as acetic acid. Okay, ethanoic acid is acetic. And if you mix acetic and water, which is exactly what we've got here, that is called vinegar. Because a mixture of that is vinegar. Okay? So if I expose a wine to air, okay, over a period of time, obviously you aerate wine initially, which improves the flavors, so I am told. I'm not a wine buff. So what happens here is that it improves the flavors. I'm guessing it draws out the berries and the teas and the cocos and whatever else people find in it, all right? But if you expose it in the bottle for a long time to oxygen, what you get is it changes to vinegar because that's acetic acid, ethanoic, and water. The next one, all right, is a combustion reaction, all right? Now, a combustion reaction is what? We're basically going to burn it, aren't we? Burn it. So if I put in a combustion reaction alcohol plus O2 gas, okay, combustion, I get CO2 plus water. So if I've got an alcohol, once again, let's take this one. I've got it like this, C2H5OH. All right? What's that? Well, C2s, H5, there we go. There's 3, there we go, and OH. It's ethanol again, plus O2, all right? And this is a delta H less than 0, which means it's exothermic. It gives off heat. Hello, that's why we burn methylated spirits, which is a methanol, okay? And that is going to give us CO2 plus H2O. Carbon dioxide and water. Same is going to be if we burn an alkane, okay? We're going to get CO2 and water, O2 gas. That's methanol plus the O2 is going to give us CO2 plus H2O. Now we're just going to balance it, and the balancing figures are 2, 3 waters, and 3 O2s, or 3 O2s there. So that plus 3 O2s as a gas does that. Similarly, if you burn an alkane plus oxygen gas, you also get CO2 plus H2O, and it's exothermic, delta H less than 0. That is burning an alkane. Why? Well, an alkane, butane, is lighter fuel. Meth, eth, prop, bute, right? It's 4 carbons. Propane is the gas they use to do the hot air balloons, I believe. Methane is the gas in a coal mine, okay? Methane, ethane, don't know what we use that for. Butane, propane, okay? And all of those, okay, pentane. Okay? Essentially what we're doing is we are using the gases to burn for energy, right? So that's the combustion side of things, all right? Now, the next side is esterification is a reaction. Now, if you remember, I covered esterification. This is number 2. Esterification is making an ester. And, for example, we could have propyl pentanoate. All right, that comes from, okay, pentanoic acid, okay, and propanol. Okay, essentially, it's an alcohol plus a carboxylic acid. Okay, alcohol plus a carboxylic acid is going to go to an ester plus water. We went through that one, I think, in the previous session. All right, then we're going to go for next one. Now we're starting a whole new that we haven't before. All right, we are going to deal with addition reactions. Addition. All right, addition. What does that mean? It means that we are going to add something. Remember, we spoke about the carbon chain and all the stalks and everything, right? Now, essentially, what we're going to do here is we're going to do halogenation, okay? An addition reaction is we are going to, in addition, we are going to break an ene to an ane, okay? We're going to start off with an ene and break it down to an ane. So let us start off with an alkene. It's an alkene plus something going to an alkane. Okay? So what are these somethings? You've got two choices here. Okay? There are halogenation. Okay? Halogen. Halogen. Oh, halogenation is adding a halogen, which means it's now a halogen, F2, Cl2, I2, Br2. It's in gas form. Okay? We're going to add it in gas form. All right. A halogen, not a halide, a halogen. We are doing that. So we're going to form a halogen, step one, or we're going to add into it and to put in hydrohalogenation for B. Hydrohalogenation. Hydro is H, halogen, Cl. So we're going to be adding essentially an acid. Okay? We're going to add HF, HI, or HBr, or HCl. We are going to be adding an acid. Right? So that's the two. Right? So all we're going to do in these reactions, the addition with the two, is we're going to break down an ene to an ane. That's what we do. So let's go. All right. Let's look at the step one first, okay? I'm going to do a mechanics of this. Let's take ethene, all right? Ethene plus chlorine, okay? And see what we get. We're going to form a haloalkane, okay? Why? Well, because we're breaking the ene to an ane and we're adding a halogen. That's what we do. So an ethene is meth-eth, okay? Double bond, there we go. Plus Cl2. Okay? Now, it's actually in this as to what's going to happen, okay? Let's see here. Now, what we're going to do is form a haloalkane, all right? We're going to take the H here, all right? The C and the C, an H and an H and an H, and we are going to add up there the Cl and the Cl into it. That's what we're going to do. All right? How do we do it? Well, first of all, we have to break the double bond. Okay? We're breaking the double bond. When we break the double bond, what do we have left? Well, we have a C, single bond C. I'm moving the H down to here now. Okay? No significance at all. It's just to give me space. And we have a linkage up there. How does this work? Okay. How do I get the fact that this broke up, one stripe broke up and yielded two more stripes? How does that work? Remember what we said. This is unfilled. So over here, let me change color. Over here, we had an electron and an electron, right? So, and this one, we also had an electron and an electron. So when I broke the bond, when I broke this bond here, when I broke the C top bond, this one, there, I was left with an electron here and an electron here. So they go to the top, there they are, right? Now they are ready to bond something else on. So what happened was the Cl, there's two of them. So they split and then they each go and sit on those spots over there. Right? So that is halogenation. What are we doing? We're breaking an ene to an ane, and in the split we end up with two chlorines or bromines or whatever go and sit on top of it. Right? That's pretty straightforward, I think, isn't it? So each time we do that, all right, then let's look at hydrohalogenation. Okay, so that one was halogenation, all right. This one is halogenation. Let me just put it in clearly over here. This is halogenation. Okay, we are taking a halogen, not a halide, a halogen, which is the two, right? It is the diatomic gas, right? That's the halogen. We're taking it, that there's two of them, so there's two spots that it goes and sits on. The next one is we're going to do a hydrohalogenation. All right? Let me put this in over here. Hydrohalogenation. All right? Basically, I'm adding an H, F, HCl, HBr, or an HI. Okay? I'm adding one of those. Remember, they are acids. Once again, it's an addition reaction, so I am adding in. So let's look at the same one. Okay, H. Okay, there's my bonds. Did I actually put those ones in on the top one? No, I didn't. See? Thought I was being clever. Okay, here, H and an H. All right? 1, 2, no. Silly me. I'm thinking of myself ahead now. I've got to do alkynes next. Okay, so what we've got here, that is correct. All right? Let me just now go back to this one. Here we go. So first of all, it's breaking it down to an, come on. So we're going to break, this process is an addition reaction. We're breaking an ene to an ane. So that's going to go, and I'm adding in here, let's add HI, shall we? Okay, and we're going to get a haloalkane again. All right, that's what we're going to get. An alkene, right, plus a hydrogen halide. Okay, let's just write it down. Alkene plus hydrogen halide goes to a haloalkane. There's the ene breaking to an ane. So I'm going to be doing this split up like that, and my H goes down there. Okay, and here the H and the I go and sit on there. All right, let me just backstep that. So remember, we have an open spot here now. and then the hydrogen halide was the H and the I, the plus and the minus. They split up and they go and join across here. And I end up with my haloalkane, CC, with an H and an H and an H and an I and an H and an H. No, the H and the I, it doesn't matter where you put it under this circumstance over here. All right? So, what have we got here? We're saying that the hydrohalogenation is once again breaking an ene to an ane. All right? Okay. Hydrogen halide, it's an acid. Yes. Okay. 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 So now let's look at, for example, butene. Let's just take this one here. Come on. Let's take butene plus a hydrogen halide. I've taken HBr. Okay. It's an ene to plus a hydrogen halide. We already know it's going to go to a haloalkane. Okay. So what do? We say butene, meth, eth, prop, but. Okay. And we said it's this character there. Plus HBr. And we know that that's going to split. Okay. I'll do the split now. All right. Put that down there. To a C. Okay. A C, C, C. And what I've done is I've created the two open spaces here. Okay, there they are. Okay, and my H and the Br is going to come and sit on these. Okay, let me be careful what I'm doing now. All right, so we've got our two open spaces now. Okay, for that to sit on top there. Okay, so we've got that going in. It's open. Two openings. Now we say, where does, the question here now is this. Okay. Where does the H plus and Br minus, because that's what they are now, link? Because you've got two openings. Okay. Now, the rule is this, and I can't remember the guy's name's rule. I think it's Markovnikov's rule. Says where the proton goes. The proton always goes where it's got the most hydrogens. So the H plus always joins maximum friends. Okay? Maximum friends wins where the most H atoms are. Okay? So the hydrogen goes where the most are. So the hydrogen will go here. Right? The hydrogen will go over there. Let me put it in red. The H goes here because it's going to join those two. All right? The hydrogen's gone to join those other two, which leaves my bromine coming in over there like that. Okay? Now, that gives us that. Well, what happens over here? All right? What happens over here? Let us take a slightly more difficult one, and let's take this, okay? C, C, double bond. I think I've got C, C. Okay? All right? This is an alkene. What is it? Well, it's an ene, and it's on, right? Let's go back to our thingies. Green, it's on 1, 2, 3, 4. Carbon atom number 2. It doesn't matter which way around I did it, 1, 2, 3, 4 the other way. It's symmetrical, right? So therefore, the alkene that we're working with, meth, eth, prop, but. So it's going to be but 2 ene. And I added HCl to it. Okay. All right. Whoops, Kevin. You have too many up there. Okay? Always check. You can see the errors I make. I make them all the time with this. Okay? Because I don't check. I just go da 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 da. Check your numbers that you've got. You can always erase it. Okay, so I've got 1, 2, 3, 4. So I'm cool on all of those. Now, I'm going to open a bond there. So I've got my CC, CC, H, 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 H there, H there, like that. Now I broke the bond here. So I've now created 2 openings there, and I have added to this HCl, which splits into H plus and a Cl minus. Now we must pick, right? So now, let me complete this here, all right? It doesn't matter, all right? It's open and open. You choose which one you want to, and you can put the H plus, put it in green, H plus there, and the Cl minus, because they are equal numbers of hydrogens are over there. All right? So that is basically how we structure the process of hydrohalogenation. Addition, okay, and we'll get to the last one now, number 3C, which is going to be hydration. All right? What happens is we're going to also take an ene, all right? We're going to take an alkene, and we're going to add water, because that is the hydration process, isn't it? Hydration is adding water. So we do that, and we form an alcohol plus, no, only an alcohol. Okay? Oops. Okay? We form an alcohol. Let's take an alkene to start off with. I'm taking the simple one here for obvious reasons. Otherwise, I'll be writing hydrogen forever. Okay? Right, check. I've got 4. So this alkene is methethene. And I'm going to add H2O to it. And I form an alcohol. The alcohol I must form has got to be CCOH, right? That's what's got to be there. Because that's an alcohol. And I've got an alkene there. How does it work once again? What did we do? We said, addition reaction means we break a bond. So there's the H, there's the H, there's the C, there's the H, there's the H. The bonds we created, or the openings, is we opened a gap here, and we opened a gap here by breaking this guy. So he went up there, these moved around to the side. Okay? That's just diagrammatically, you know. You're going to see them drawn slightly differently, but just schematic. That's what this is. It's the structural version, isn't it? So we say that, and now we said we have H2O. So H2O in this case splits into, let's use blue. It splits, that's not blue. Okay, blue. This splits into an H plus and an OH minus, right? And the OH minus goes there, the H plus goes there, and there you've got it. All right? All I've done is the OH goes at the end. I've put it there, okay? Just to illustrate. When you'd write it, you would write it in that format. Okay? So that's all pretty straightforward, isn't it? Okay? Now, once again, where do they go? Once again, we're now going to take a slightly bigger one and hydrate that. All right? Let's take here 1, 2, 3, 1, 2, 3. Yeah, let's take this one. Okay, like that. Da 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 da. Okay, nope, you're not there, and that's a 2. So that's got those 2 there. 1, 2, 3, 4. Okay, now we can put our H's in. Okay, right, now what have I got? Meth, eth, prop. I have got propene here. It's an ene, and I'm now going to add water, hydrate it, which means I'm going to get an alcohol. Okay, you have to know that. So I'm going to get an alcohol. How do I do this? What do? I say, right, let's go through the mechanics. C opens up, H, this C, H was there. This is now a single bond over here, all right? And we have opened up the two bonds on top, all right? This we know splits into an H plus and an OH minus, okay? The hydrogen proton and the OH minus, the hydronium ion, the hydroxyl ion. This, by the way, is the hydroxyl, goes there, okay? Because that's how our water splits up. Now, where does the hydrogen go and where does the OH go? The hydrogen, once again, this Markovnikov rule, all right? He goes to where the H plus always goes where the most friends are. And where are the most friends? There, and the OH goes there. Okay? So you are going to form an alcohol like that. This needs, now you need to know this, all right? I'll keep it red. NB. This needs steam plus strong acid. Steam and a strong acid. Okay? These are your catalysts. All right? They are the catalysts. Okay? Now, the last one that we're going through, and I am running over, I do apologize, but I'd rather get this finished if you don't mind. Okay, let me just see where I am. Page 5. All right. I'm going to now do, okay, hydrogenation. Hydrogenation. Okay, this is basically adding hydrogen gas. Once again, it's an alkene plus H2 goes to an alkane. All right? Can you see the pattern? Alkene, let's do this one. I've got a 3, I put a 4. Okay, H, 1, 2, 3, 1, 2, 1, like so. All right? Now, I'm going to break open that bond, right? Okay, let's do it a different way this time. CC, put the H, boom, 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 boom. And what have I done? We have opened up, okay, we have opened up there and there. Space to put in. This H2 here splits into an H plus and an H plus, and they come and they sit over there. All right, and we don't have to worry. So alkene goes to an alkane. Essentially, butene with hydrogen goes to butane. Okay, goes to butane. Right, and the catalysts for this, all right, the catalysts for this that you need to know, I'll keep it in red. NB is platinum, nickel, or palladium. Platinum, nickel, or palladium. Okay? All right? No oxygen present. Important, no O2 present here. Okay? NB. Okay? Because it'll contaminate it. Because oxygen can also link onto the C. Okay? I'm going to stop there because then I'm going to go on with elimination reactions in the next one. As I say, I'm sorry I've gone over the top. There's a very nice summary that I'll try and do and post onto the website that you could go and download. I'll do that towards the end of the process and try and summarize this into one basic little diagram that we have to remember. Cheers. I know it was a bit long. My bad. Sorry. Cheers. Bye.